Welcome to Module 7, Supporting Network Services. This module covers the services that run on networked hosts, the internet and embedded appliances that support them, and how to troubleshoot networks when things go wrong. By the end of this module, you'll be able to summarize services provided by networked hosts, compare internet and embedded appliances, and troubleshoot networks. These three outcomes map to the three lessons ahead. Lesson 7.1, Networked Host Services. This lesson maps to 2A plus 2.2.0.1.2.0.1 objectives. 2.1, comparing TCP and UDP ports, protocols, and their purposes. And 2.3, summarizing services provided by networked hosts. By the end of this lesson, you should be able to answer: what services are commonly found on modern networks? What port numbers are associated with those services? How does a web server function? What services do email systems and servers use? And how do remote access and monitoring services help system administrators? Modern networks run a handful of core service categories. Web services handle websites, apps, and APIs over HTTP and HTTPS. File sharing uses FTP, SFTP, and SMB. Email services use SMTP, POP3, and IMAP. Name resolution is DNS. Address assignment is DHCP. Remote access covers SSH, RDP, and VPN. And monitoring and management covers SNMP and syslog. Here's a reference chart mapping each of these services to its port number, worth having memorized, since it comes up constantly on the exam and on the job. A web server hosts websites and applications, listening for requests on HTTP, port 80, or HTTPS, port 443. It uses DNS to translate domain names into server IPs, then responds with the requested content, HTML, images, scripts. When you type www.example.com, DNS resolves the address, your browser requests the page, and the server responds. Email systems rely on a few key protocols. SMTP, port 25, sends outbound mail from client to server and between servers. POP3, port 110, downloads mail from the server and removes it, storing it locally. IMAP, port 143 or 993 secure, syncs mail across devices and keeps messages on the server. And MX records are the DNS records that identify a domain's mail servers. Remote access services include RDP on port 3389 for full desktop control, SSH on port 22 for secure command line access, and VPN for a secure tunnel into the corporate LAN. Monitoring and management services include SNMP for monitoring network devices, syslog for collecting logs, and the alerts and reports that help admins troubleshoot quickly. Here's what this lesson covers: directory and authentication servers, remote terminal access servers, time servers, network monitoring servers, file and print servers, database servers, web servers, HTTPS, and mail and mailbox servers. Time for an activity: network services. Working in pairs or small groups, use the virtual lab to identify a file/print server, web server, mail server, and directory server. Configure one service of your choice, say a basic FTP server or a web server using HTTP or HTTPS, and document its purpose, protocol, and port, and the steps you took. File and print servers rely on a few key protocols. Server Message Block, or SMB, handles Windows file and printer sharing, with its modern version called CIFS, running over TCP port 445. NetBIOS, or NetBT, is an older Windows networking method that handled name resolution and file sharing before DNS, mostly replaced now, but still seen in legacy systems. And FTP transfers files between client and server over ports 20 for data and 21 for control, though it's not secure, so SFTP or FTPS is preferred today. Database servers store large amounts of structured and unstructured data. Relational databases, using SQL, are the most common type. They link data by relationships between tables, like linking a customers table to an orders table through a shared ID, and an orders table to a products table the same way. Non-relational databases trade that rigid structure for flexibility, storing data as graphs, documents, or key-value pairs instead, useful when data doesn't fit neatly into rows and columns. A web server listens on HTTP port 80 for standard traffic, or HTTPS port 443 for encrypted traffic. Here's the flow. Your browser sends a request, the server processes it, and responds with the page data, HTML, CSS, images, scripts. If the request fails, you get an error code, like 404 not found. A URL breaks into three parts: the protocol, HTTP, or HTTPS, the fully qualified domain name, like www.example.com, and the file path, like /about/index.html. Here's a look at how a web server actually handles a request end-to-end, from the browser's initial ask through to the page loading in front of you. HTTP on port 80 sends data unencrypted with no client or server authentication, insecure for anything sensitive. HTTPS on port 443 adds TLS encryption on top of HTTP, using a public and private key pair for authentication and confidentiality. That's what secures logins, payments, and private data in transit. SMTP, Simple Mail Transfer Protocol, sends outbound email between mail servers. It uses two ports for different purposes: port 25 for server-to-server delivery, and port 587 for client-to-server submission. Separating the two improves security and helps manage email traffic. POP3 downloads email to the client and usually removes it from the server, best for single-device access over port 110 unencrypted or 995 secure. IMAP keeps email on the server and syncs across multiple devices, preserving folders and organization. Best for multi-device access like phone, laptop, and webmail over port 143 unencrypted or 993 secure. LDAP, the Lightweight Directory Access Protocol, queries and manages user accounts in a central directory. Microsoft Active Directory is a common example, over port 389 unencrypted or 636 secure. AAA stands for Authentication, verifying identity, authorization, granting permissions, and accounting, tracking usage. The AAA components are the supplicant, the device or user requesting access, the network access server, the gateway like a wireless controller or VPN server, and the AAA server itself, using protocols like Radius or TACAX+. The term terminal dates back to early teletype or TTY, devices used for configuration, and a terminal emulator is software that replicates that TTY input and output today. Modern remote terminal access uses SSH on port 22 for secure command line access, Telnet on port 23 for the older, unencrypted equivalent, and RDP on port 3389 for full remote desktop control. Network Time Protocol, or NTP, keeps system clocks synchronized across a network using UDP port 123, critical for security, logging, and authentication, since things like Kerberos require accurate time. Clock accuracy is measured in stratum levels. Stratum 0 is an atomic clock, the most accurate reference. Stratum 1 connects directly to a Stratum 0 source, and Stratum 2 and beyond sync from Stratum 1 servers, and so on down the chain. Here's what an NTP hierarchy actually looks like in practice, each stratum level syncing its time from the one above it. SNMP, Simple Network Management Protocol, monitors network devices like routers, switches, servers, and printers, using agents on each device reporting to a central management system, over ports 161 for queries and 162 for traps and alerts. It can alert an admin the moment a switch port goes down. Syslog collects and stores event logs from multiple devices in one place over UDP port 514, helping with troubleshooting and security monitoring. Think of it as a diary for your network. Firewall, router, and server logs all get written to a single syslog server, so you can review them later to understand what happened. Welcome to Lesson 7.2 on Internet and Embedded Appliances. In this video, we'll examine key networking services and appliances, mapping to CompTIA A plus Exam Objective 2.3, which covers summarizing services provided by networked hosts. By the end of this video, you will understand how proxy servers work, how spam gateways function, how load balancers increase resource availability, the purpose of unified threat management systems, and identify common examples of IoT devices. A proxy server acts as a middleman between a client and the internet. It forwards client requests to websites and services, then sends the responses back. It can also filter traffic, cache content, and hide client IP addresses, such as when a company blocks access to social media. A spam gateway is a specialized mail server that filters incoming and outgoing email. Using rules, blacklists, and spam detection algorithms, it stops threats like malware, phishing, and junk mail before they reach the user. A cloud-based filter removing 90% of spam is a common example. Load balancers increase availability by distributing incoming traffic across multiple servers. This prevents any single server from being overwhelmed and provides fault tolerance. If one server fails, traffic is automatically routed to healthy ones, ensuring a more resilient application. A Unified Threat Management System, or UTM, is an all-in-one security appliance. It combines a firewall, intrusion detection and prevention, anti-malware, VPN support, and content filtering. This simplifies network security management, particularly for small and medium businesses. IoT devices are everywhere. Examples include smart thermostats like Nest, smart speakers like Amazon Echo, IP security cameras and video doorbells, smart locks, and wearables like the Apple Watch. Industrial IoT sensors are also vital in sectors like manufacturing and healthcare. This lesson covers several critical areas: proxy servers, spam gateways, unified threat management, load balancers, Legacy systems. Embedded systems like SCADA and the broad category of Internet of Things devices. Proxy servers function as intermediaries, forwarding requests and checking responses. They are useful for enforcing policies and improving performance through content caching. They can be transparent, where the user is unaware, or non-transparent, requiring manual configuration. This diagram illustrates the proxy server's position in the network. It sits between you and the Internet, sending requests to a target on your behalf and then returning the response to you. Here is a closer look at the request and response flow. Notice how the client never communicates directly with the destination server. The intelligent web filtering system manages the entire interaction. When comparing spam gateways and UTMs, remember that a spam gateway specifically focuses on email filtering. A UTM appliance is much broader, consolidating firewall, IDS/IPS, antivirus, content filtering, and data loss prevention into one single device. This graphic shows how spam gateways act as a secure cluster in the cloud, stopping threats before they ever reach your internal email server, thus protecting your customers and your network. Load balancers are essential for high availability, scalability, and performance. By spreading the workload across multiple servers, they ensure that an e-commerce site, for example, remains operational, even if individual servers experience issues. Finally, this diagram summarizes the load balancing process. Traffic from various users hits the load balancer, which then distributes those requests evenly across the server pool, optimizing performance and reliability. Next, let's discuss legacy systems. These are end-of-service systems that are no longer supported by their original vendor. Organizations often retain these systems to support services that are too complex or expensive to migrate. However, this creates security risks, as the vendor is no longer providing patches for new vulnerabilities. Moving on to embedded systems and SCADA. Embedded systems are specialized, dedicated devices built to perform a specific function, such as medical monitors, ATMs, or smart devices. Industrial control systems, or ICS, are designed to automate and manage industrial processes like conveyor belts, pumps, and valves found in factories and power plants. SCADA, or supervisory control and data acquisition, involves large-scale ICS used for monitoring and controlling critical infrastructure, such as electric grids and oil pipelines, providing both real-time monitoring and remote control. This diagram illustrates a typical SCADA-controlled interface, allowing operators to monitor critical infrastructure in real time from a centralized location. Now, let's explore the Internet of Things, or IoT. These are everyday devices connected to the Internet to share data and provide services, ranging from smart home speakers and lights to industrial sensors. IoT devices often rely on hubs or cloud services for automation and remote control, but they introduce unique security risks, including weak default passwords and limited patching capabilities. As you can see, a modern smart home ecosystem connects numerous device types through a single central hub or mobile application. Welcome to Lesson 7.3, Troubleshooting Networks. This lesson covers A+ Exam Objective 5.5, which tasks you with troubleshooting network issues in various scenarios. We will cover troubleshooting wired and wireless connectivity, network speed issues, VoIP performance problems, and resolving limited or no connectivity scenarios. To practice these skills, we will use a simulation where you will identify root causes of network issues, apply appropriate solutions, and document your complete troubleshooting process. When troubleshooting wired connectivity, remember to start at layer 1. Common issues include damaged cables, port flapping, or duplex mismatches between the device and the switch. Speed issues often stem from congestion, malware, or hardware failures. Effective troubleshooting requires identifying the scope of the problem and analyzing traffic patterns to find the root cause. To summarize this module, remember that network systems are complex and diverse. Understanding how to manage these appliances and troubleshoot connectivity is vital for any IT professional.